Is it in front of you? You can check it. Okay. So this is, yes, is it in front of you?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
So calculation of a molar ratio of a given mixture or given crude product, that's a percentage of product calculation or enantiometric excess by using NMR technique. Okay. In that first problem, the H1 NMR spectrum of dilute solution, which is prepared by mixing of acetone and dichloromethane, that is DCM, in a CdCl3 as a solvent, exhibit two singlets of intensity 1:1. So calculate a molar ratio of acetones to dichloromethane in your solution. So first you have to draw the structure and find out which types of proton and how many signals are present in your compound. So acetone, total number of hydrogen present in acetone. So 6 hydrogen present in acetone, and that 6 hydrogens are equivalent. So 6 hydrogen gives one signal, where in case of DCM having 2 hydrogens, and that is also showing intensity 1:1. So 6 hydrogen and 2 hydrogen both are showing 1:1 intensity in your that mixture. If you're having equivalent number of acetone and dichloromethane, then the case will be different. That is a 6 hydrogen versus 2 hydrogen. So your intensity will be 6:2. Okay. So if you're looking number of hydrogen in both cases, so that is a one number of signal in acetone is 1, so number of signal in dichloromethane 1, so you are getting 2 intensity, that intensity of a different that compound or that acetone and for dichloromethane. Number of proton in acetone 6, number of protons in DCM is 2 proton. So as if both are equivalent, that is a 50-50% in your mixture, then the intensity or that integration of proton will be like this: 6:2, 6 protons and versus 2 proton. But in given example, intensity given as a 1:1, that is a 1:1. So first thing, they are not in 50-50%, they are not prepared by mixing of 50% acetone and 50% dichloromethane. So when this intensity become equal, that is the mixture which is having 6 hydrogen from acetone is matching with 6 hydrogen of DCM. So to become 6 hydrogen of DCM, that DCM molecule will be 3 times more than acetone. That is a required condition. Acetone having 6 hydrogen, DCM having 2 hydrogen. But to become 6 hydrogen for DCM, DCM must have 3 mole is higher than that of acetone. So that become 3 into 2, 6. So if you're taking 1 hydrogen and 3 DCM, then you will get 1:1 intensity. That is in molar ratio is a 1:3. So let's calculate by using formula. So formula used for this is a molar of a compound or a major product divided by molar mole of that B, or it is for minor product, is equal to intensity of a compound or major product, or that is integration given in mm of A, divided by the number of proton at that compound or for a particular P. Okay, and to this divided by intensity of a B or integration in mm of B to the number of proton of that integration or that peak which are considered for the calculation. So in case of this acetone and DCM, the formula is written like this: mole of acetone divided by mole of DCM is equal to intensity of acetone as given in a problem to the divided by number of proton in acetones, and to hold this divided intensity of a DCM divided by number of protons in DCM. So intensity in both cases it is given 1:1 intensity. So you have to use 1 intensity for acetone, 1 intensity for DCM. Number of proton in acetone, so there are 6 proton. So 6 proton in acetone, and number of proton for DCM in 2 proton. So that become 1 by 6 divided by 1 by 2. That is 1 is the intensity of acetone, 6 is a proton, divided by 1 of intensity of a DCM, divided by 2 protons of the DCM. So therefore is equal to 1 by 6 into 2 by 1. That denominator is here into multiplication, that is 2 by 1. So by calculating, that is 2 to 1, and this is getting 3. So it is a 1 to 3. So therefore molar ratio, that is the mole of acetone and a mole of DCM is equal to 1 to 3. So number of mole of acetone is 1 and number of mole of DCM is 3. So therefore molar ratio for this solution is 1 to 3. That means 1 acetone and 3 DCM in your solution. So that your solution is 1 acetone and 3 mole of DCM. So that they give intensity 1 to 1. So if 1 acetone, total number of hydrogen. Yes, how many hydrogen in acetone? 6 hydrogen. If you are taking 3 DCM, so 3 DCM sharing 6 hydrogen. So this hydrogen become equal and they show the equal intensity or same intensity. So that is the molar ratio. Then what will be the percentage of acetone and percentage of DCM in the solution? Yes, anybody? So percentage of acetone, that is 1 of acetone and 3, that is a 25 to 75%. That is 25% acetone and 75% DCM is in your mixture. So that mixture is prepared by taking 25% acetone and 75% DCM. So that is your ratio of. Next problem, which is asked in CSIR exam. Reaction of a styrene with a bromine gives a mixture of a regioisomer A and B. The H1 NMR spectrum of this mixture shows 4 signal amongst other. That is, these signals are mixed. Okay, we don't know which is signal of what, which product. At 5.17, 3.53, 3.15 and 2.00 delta ppm with a relative intensity of 2 to 1 to 1 to 6 respectively. So calculate molar ratio and percentage of AB form. So by using that NMR, you have to calculate molar ratio and a percentage of that A and B form. So first, you have to write reactions of styrene with HBr. So this is simply addition reaction and a major product, minor products. So according to what major product form, which, so this is major product formed by Markovnikov's rule. In addition reactions, that negative part of reagent, that is the Br minus, goes to that carbon which is getting more substituent. So here pH is a substituted, or that is a formation of carbocation which is more stable here. So this is a major product and called as a Markovnikov's product. And this is a minor product where Br is attached to terminal bond, that is here CH2. Yes. So now you have to find out the peaks for this. Okay, so we are not taking pH protons here. It is not given. It is given 5, below 5, below than 6 delta. So there is no aromatic protons are given, but other these protons are given from the product. Okay, so assigning the signal to above product from giving delta's value, that is 5.17, 3.53, then 3.15 and 2 delta. So let us assign the values. So this is which is attached to Br and that pH. So it is attached to pH as well as Br, in between aromatic and Br. So this is having highest delta value. It is more deshielded. So it is having higher. And this is CH3. Okay. we are assigning afterward out of this. So this is gaining the lowest one, 2 delta, because it is away from that withdrawing groups. Now in case of this CH2 is attached to aromatic and this CH2 attached to Br. So if it is attached to Br, its value in the range of 3 to 4 delta, and it is also attached to pH. So pH, if CH2 attached to pH, its value more than 3.4 delta. So definitely 2.00 not in second minor product, it is going to CH3, and this two value goes to this CH2 CH2. So out of this, bromine is a withdrawing, so it is having more delta value, and this is attached to pH, so it is having less than that. So this is first delta 5.17 due to that Br and pH. Then it is a 2 delta, lowest one. Then it is a 3.15, and this is 3.53 because of bromine. Now, intensity or integration for this. So 5.17 is a 2. Okay, before that, number of protons for there here. So number of proton for this is a 1 proton, because it is attached to 3, remaining is 1 proton, 3 proton. This is 3 proton. This is 2 proton, 2 proton. Okay, so this is signal due to 1, 3 proton, 2 proton, 2 proton. And intensity for integration given as a 2 for that first signal, then 6 for that last signal. So this is 2116. Okay, so this is 26, and in this you're getting 1 1. Okay, so this is having same hydrogen, therefore it is a 1 1. So this is having 1 to 3, that is a 2, and 6, that is following hydrogens. Yes. Okay. So by assigning this, now for calculation, you can take any picks from major product and any pick from the minor. Okay. So any pick from that given first that major product, you can take 5.17 and 3.15, or 2 and 2 3.15, or any one from the major and minor to compare their molarities or the mole ratio. Okay, so this is the reaction and their H1 NMR. First you have to assign this, and then by using this formula one can calculate a mole of this mole ratio. So mole of a major product divided by mole of a minor product, or A versus B. So integration of any peak in A divided by number of peak at that integration. So the peak you are chosen, take the number of proton for that integration. That is a condition. Integration in any peak B divided by number of proton in that integration. Okay. So here let's take proton from 5.17 from the major product and 3.53 peak from the minor product. So peak is a 5.17 having 1 hydrogen, and intensity or integration is 2. This is a 5.35 sorry 3.53 number of protons for this 2, as we seen last slide, and number of integration given from the question is 1. So use this in above data, then you will get the molar ratio. So using that intensity of any peak, that is a 2, integration 2 divided by number of proton 1, and 2 divided by integration of any peak in B. So we are choosing this intensity is given 1 divided by number of proton in that peak. So for that peak is the number of proton is 2. So 2. So by taking this half on, it become multiplying 2. So 2 into 2, 4. So mole of A or major product divided by mole of B minor is equal to 4 by 2. So the mole ratio become 4 to 1. So major product is in the 4 ratio, and minor product is in 1 ratio. So that is the mole ratio. That is a major product form 4 times more than that of minor product. It means major product is 4 and minor product is 1 time. So from this one can calculate the percentage. So let's look how to calculate percentage. So molar ratio of majors to minor is 4:1. Yes, it is calculated as previous. So percentage of major and minor. So total molar ratio become from that molar ratio 4 plus 1 is equal to 5. Total is a 5 molecules like this. So if total molar ratio correspond to that 100%, so we get a term 4x plus 1x is equal to 100%. So x is a common factor which is getting the 100%. Calculate x, you are getting percentage of that major and minor. So 4x plus 1x is equal to 100%. Therefore, it becomes 5x is equal to 100%. So 5x is equal to 100. Therefore, that x is equal to 100 divided by 5. So it becomes 20. So x you are getting 20 here. Now use that x in major. So percentage of major product is equal to 4x. So 4x, so 4 into 20, it become 80. So major product is in 80%. And what about minor product? So minor product is 1x. Therefore, 1 into 20 is a 20%. So minor product percentage of minor product is 20%. So that become ratio 4:1. That ratio is a become 4:1, or it is a molar ratio. So that is the calculation of molar ratio and percent product. So anybody having doubt in this?
No, sir.
Okay. So that is simply calculation. If you understand, you can solve any problem. Okay. So we go immediately on third. Okay. Acetyl acetone exhibit in a keto-enol form at 20 degrees Celsius. The chemical shift of proton of each form is given below. Okay. The in a NMR spectrum, the integration at 3.61 and 6.10 delta ppm are 44 mm to or 44 mm and 0.4 mm respectively. So calculate the percentage of keto and enol form at equilibrium. Okay. So we know that acetyl acetone having keto as well as enol form in room temperature also due to stability, enol form having hydrogen bondings. So this compound remain in keto-enol tautomer. If any beta diketo compound, they refers to undergo enol form also. And this is the data given keto and enol form and their delta values. This CS3 is 2.09, 3.61, 2.09. This CS3 is 7.1, 6.10, and 2.30. Which two peaks are given in problem? Yes, which two values are given from that keto and enol? 3.61 and 6.10. Now you have to find out the number of hydrogen at that particular signal. That is the main. So how many hydrogen present at 3.61?
2.
2 hydrogen. And at 6.10? 1 hydrogen. Okay, so we are getting hydrogen number at that particular peak or particular signal. And integration at 3.61, 44 mm, and at 6.10,
4 mm.
4 mm. So we are getting intensity or integration and their number of hydrogen. So we can use in our formula, yes, and we can calculate their molar ratio, and from molar we can calculate percentage. Okay, so let's go. That is a form, that is the keto form, and this is enol form. Signal delta ppm given, yes. So delta given, that is to consideration 3.61 delta and 6.1 delta. Now number of hydrogens or number of protons. That proton is 2 proton and 3 proton. Okay. So number of proton in this 3.61, 2 proton at that 6.10 delta is a 1 proton. At that signal integration given, so this is a 44 mm and this is 4 mm. So intensity, or you call as the integration, 44 mm and 4 mm. So using this, one can calculate a molar ratio. So molar ratio formula, mole of keto forms divided by mole of enol form is equal to integration of keto form to the number of proton at that signal or that integration, divided by integration of enol form to the number of protons at that integration. So integration in keto form given, yes, how much integration given?
44.
44, and number of at that integration, that 44,
2.
2 in 2, yes, and integration at enol form
4.
4 mm, that is 4, and number of proton at that integration is
1.
1. So by using this value, okay, so 44 divided by 2, to that divide 4 by 1, so this become 44 divided by 2 into 1/4, that is by taking it up, so it become 11 to 2, that is 444 become 11 by 2. So this keto form versus enol form become 11 by 2. Therefore mole ratio become, yes, mole ratio, so it become 11 to 2, or we can write as a 5.5 to 0.1. Okay, that is the mole ratio. Okay, by using that mole ratio, this total of mole ratio, that is 11 plus 2, that become 13, so that correspond to 100% product or 100%, yes. And take a common factor. Okay, here calculate a percentage of major and minor product. So molar ratio of ketos to enol is 11 to 2, therefore percentage of keto-enol form, so total molar ratio 11 plus 2 is equal to 13, and that 13 correspond to 100%, or we can take as a total molar ratio correspond to 100%. Therefore 11x plus 2x is equal to 100%. Okay, you can use different maths way. This is like a simple maths problem. Okay, so 11x plus 2x is equal to 100%. Therefore 11 plus 2 become 13x
13.
become 100. Okay, 13x is equal to 100%, that x is equal to 100 divided by 13, so it become x is equal to 7.69. By calculating, it becomes 7.69. Therefore use that x in above, so therefore your major product is 11x. Percentage of major product is 11x. Therefore percentage of major product or keto form is equal to 11x, that is 11 into 7.69 is equal to 84.62%. So by calculating this x, use x in to 11x, so you are getting to 100%. Then what will be the percentage of minor that enol form here? Yes, so it becomes 2x, and x is a 7.69, so multiplying with 2 it becomes 15.38. So keto form is 84.62 and enol form is 15.38%. So that is a percentage at 20 degrees Celsius. So you will observe that it is that acetone at 20 degrees Celsius, nearly 85% in keto form and 15% in enol form. Okay, so that is the answer. By using NMR, we calculate this. Okay. Okay. Next problem. Directly we are taking. So reaction of propane with HBr gives a major plus minor product with a molar ratio S to 2. If NMR of this crude mixture is recorded in CdCl3, what will be the relative intensity of methyl group in NMR? So reaction is given, this is a propene. Propene react with HBr gives major plus minor. So Br attaching at this secondary carbon giving major product according to Markovnikov's rule. And if it has attaching to terminal, it is a minor. And you are asking that CH3 and this CH3, what will be the intensity? If they are in 1:1, what will be the intensity? If they are forming 50-50%, so intensity will be 6 to 3. That is 6 hydrogen in first case, or major having 2 methyl group which are equivalent, and second having only 1 methyl group. Therefore, intensity become 6 to 3. But that is not given because molar ratio is to 1. So molar ratio is H to 2. Number of methyl proton in this 6 and in this 3 proton are there. If equivalent, its intensity will be that 6 to 2. So for intensity, multiply that number of proton into molar ratio. So that become 8 into 6, it become 48. Okay. So 48 and this 2 into 3, 6. So intensity will be 48 to 6. Are you getting this? Yes. Are you getting?
Yes.
Yes, sir.
So 8
Yes.
molecule of this and 2 molecule of this. So number of CH3 of this 8 moles. So that 3 into 6 into 8, because each contributing 6 protons. So 8 molecule of that major product. So therefore the methyl hydrogen become, how many methyl hydrogen become? 48 hydrogens in that ratio, and this is having 2 mole. Okay, that is product form in 2 mole. So number of proton in this only 3. So 3 into 2, it become 6 hydrogen. So at that molar ratio, this first show 48 methyl hydrogen, and this is showing 6 methyl hydrogen. Therefore, by simplifying this 48 to 6, it become 8 to 1. So their intensity of methyl is a 8 to 1. Okay, so this is a intensity of this. So this is a copy pasted here, intensity of intensity of methyl is 48 to 6, or it is simplifying 8 to 61. So there is correction, not it is pasted from previous example. So intensity of methyl is 8 to 1. Okay, is that clear? If they are asking intensity, just multiply number of hydrogen at that particular peak or particular group into number of moles, how many molecules present. So that is giving the intensity. Next one, what is question?
Yes, ma'am.
So the NMR spectrum of unknown percent mixture prepared of para-dichlorobenzene and 1,3,5-dichlorobenzene recorded in CdCl3. It exhibits two singlet of intensity 1 to 3 respectively. So what will be the percentage of mixture? So unknown percent is prepared and you record its NMR. So you are getting 1 to 3 intensity ratio, that is 1 for para-dichlorobenzene and 3 for 1,3,5 trichlorobenzene. So this is structure, para-chloro and trichloro. Number of signals, it is giving one signal because all 4 are equivalent hydrogen. In this also you are getting one signal. The number of protons on that signal become 4 hydrogens. 4 hydrogen giving one signal, this 3 hydrogen giving 3 hydrogen. Therefore, intensity given is 1 to 3. That is from your data 1 to 3. So use that formula, number of moles or major or minor. So this become mole of para dichlorobenzene to the mole of 135 trichlorobenzene is equal to intensity of para dichlorobenzene to number of proton at that particular peak or that para dichlorobenzene to this divided intensity of 135 trichlorobenzene divided by number of proton at that integration in 135 trichlorobenzene. So by using that intensity of is first intensity 1, number of proton in dichlorobenzene 4 divided by intensity of 135 is 3 and number of proton for trichlorobenzene is 3. So it become 1 by 4 into 3 into 3. So it become 1/4. So molar ratio is the 1:4. So molar ratio is 1:4. That is 1 para dichlorobenzene and 4 mole of 135 trichlorobenzene present. Okay. Now from this calculate percentage 1:4. Therefore, that 1x plus 4x is equal to 100%. By this ratio, one can calculate percentage 1:4, that is the 1x plus 4x is equal to 100. Therefore 5x is equal to 100, x become 20. Okay, x become 20. Therefore percentage of para dichlorobenzene is equal to, which is in one form, so it is a 1x is equal to 20% and percentage of 135 trichlorobenzene is 4x. So 4x into become 4 into 20, that is a 80%. Okay. So that is the percentage of mixture which is prepared and getting NMR signal. So that is the calculation of molar or percentage. And from percentage, one can calculate the enantiomeric excess also. That is applicable for enantiomer formation. We are taking simply different mixture. Okay. These two are questions for you. Take a screenshot of this and solve it. Take a screenshot of your mobile or print screen of your laptops and solve it. Okay. Then another example, that is based on first example. Solve it. Intensity is different. Take a screenshot. Okay. So for enantiomeric excess, it is given two product like our styrene or propene. Two product are formed. They are a regioisomer, not enantiomer, but one can calculate its percentage, and once the percentage calculated, one can calculate enantiomeric excess is equal to major product, percentage of major product minus minor product divided by major plus minus into 100. So enantiomeric excess is calculated by this. So all of you taking that screenshot?
Yes.
Yes.
Yes, sir.
Okay.
Yes, sir.